All right, well, thanks, Chris and Jasmine. Appreciate that. So we're going to hand it back to Louis for some cleaning and residue management here next. I do want to remind everybody that we have questions already in the queue. AOS@rockymtn.com. Get those questions in, and that segment will be next. So we do have a couple questions already, and we'll get to those questions here very shortly. So Louis, take it away.
All right, thanks, Chad. All right, so the next section we're going to cover is going to be self-leveling cleaning system, and also how the return system actually affects the cleaning system. All right, so bottom line is the cleaning system for you guys that's been running legacy combines since, flagship combines, since 2002. They all had self-leveling cleaning system. And what I mean by self-leveling cleaning system is the whole cleaning system, what you see on here, the whole thing self-levels underneath the combine. Not just the grain pan, not just the sieves, the whole complete cleaning system will self-level. And one of the reasons we went to that system is because of this grain pan assembly here. Okay, so the grain pan, its main purpose is to grab the material and start lifting it and shaking it. So if I turn around, let's say I don't have my rotor speed adjusted properly, or I don't have my module height adjusted properly. So I could be very well overfilling this side of the grain pan, or this side, or too much in the middle. Okay, depending on module height, rotor speed, depends where material is going to fall on there. So that's what you're tweaking when you're actually adjusting those two. If it falls all in the middle, the pan starts to shake, and by the time the grain gets from here to here, hopefully the thickness of grain is equal all the way across. If the grain is equal all the way across, I don't care about the chaff. The chaff does not matter. Chaff is light, chaff will blow away. It's the thickness of grain is what I'm looking for. If it's level at the back of the grain pan, that cleaning system will absolutely not throw over. Okay? Did you hear me properly? The system will not throw over. It is almost impossible. Even if you had bad adjustments on the sieves, you would have to be totally out to lunch for it not to work. So the key is always get it level. So,
how is that monitored?
All right, question is how is that monitored? Well, the guy that monitors it is sitting in the seat and he's looking at his sieve loss monitor. Okay? If it is not level, if I have too much grain over here versus over here, that pile of grain will just carry on right through and fall on the sensor pad. Okay, and this over here has no grain, it only has chaff. Now this is going to go out here, and the wind is always going to take the path of least resistance. Okay, so if I have nothing on this side, and I have a nice blanket of grain over here, where's the wind going? Right there. This one rides, this one blows. So now all of a sudden, as soon as I see too much sieve loss, should I adjust my fan speed? Should I adjust my top sieve? Should I adjust my bottom sieve? Should I adjust my pre-sieve? I kind of like the way you think, okay? Because what's going to fix it? Rotor speed and module height. So now let's go back and think about this. Why is it every time that I see a dirty sample in the tank and I throw over, the first thing that comes to mind is to adjust the fan speed? Same stick, okay? All right? Because we're all guilty, sorry. It has absolutely nothing to do with the cleaning system. And remember what I said when we first started again? You start adjusting the combine from where? from the front, and you work your way back, and you find the problem sooner. And you would have found the problem sooner if you adjusted the modules and the rotor speed before playing with the fan, top sieve, bottom sieve. Unfortunately, we're all misprogrammed, and that's when we normally say, I've got 10 bushels per acre loss, Louis. This combine's no good for nothing. And oh, by the way, you tried everything, right?
How about the concaves? Did you adjust them?
Absolutely. The question was, how about the concave? Would I adjust them? Absolutely, because that's, the minute I move the concave, it totally changes the location of this pile. I change the rotor speed, it totally changes what's on there. So that's why I'm stressing on this to drive you guys back to understanding what the grain pan does. If it's not level, I'm going to have a dirty sample and I'm going to throw over. So every time, start from there, work your way in towards the back.
So now on an occasion where you're on a hillside, what happens then?
All right, question is, occasionally when I'm on a hillside, what happens then? All right, so now, I just said this whole cleaning system is self-leveling. So if I go on a hillside, guess what? My combine's like this, but the cleaning system goes like this. Question was, it's supposed to. Yes, it is supposed to. Okay, but it has restrictions. Okay, it's only good for 12% slope. 12% slope is big. That's big, okay? Now if I go beyond that, like I'm working in Idaho and Spokane, Washington, that even goats can't make it up the hills. So now all of a sudden combine's like this. It tried to level, but it's still like this because this is 12%. That's why they need the side hill combines. So then the combines level off as well as the cleaning system, so they got the best of both worlds. But you and I, 12% around here is, she's a pretty big slope, okay? All right, so again, the key, as long as you remember, the key is if it's level with grain all the way across, that cleaning system is going to work.
So to check that, you have to do a stall on your combine.
Okay, to check that now, question is, to check this, I have to do a kill stall. And the answer is that's the only visual you're going to get. Okay? But if you're smarter than the combine, okay? If you're smarter than the combine and you get thinking about it, if I'm throwing over, it means my grain pan is not adjusted properly. Okay? If you keep thinking that way, you're immediately going to start adjusting rotor speed and concave heights. And what do you think is going to happen to your sieve loss sensor pad when it becomes level? It goes down and down, and then that's how I can tell. I'm adjusting rotor speed and concave, trying to tweak it. And then finally, I look at the sensor, and it's going like down, 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 down. Whew. Okay, I'm going the right direction.
No kill stall required.
Comment is no kill stall required. Yes, kill stall is still required. Okay? Yeah. Kill stall is always your last resort before the gallon of gasoline. It's always my saying. When you're ready to throw the gallon of gasoline and burn the bitch, do a kill stall. Okay? It'll save you a lot of money. And we'll talk a little bit about kill stall here in a minute. So, all right, pre-sieve. On here, pre-sieve. I still stick to my old rule that I've been using forever, and it always keeps me alive. Okay? The rule is you never, 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 never close that sieve any tighter than 3 millimeters. You got that? And then you never open it any bigger than the size of the kernel. So I'm doing canola. What size am I going to be? Huh? 6 in canola? What did I say? Thickness of the seed. Am I going to go below 3 millimeter? No, never, never go below 3 millimeters. So that'll be the lowest you ever go, 3 millimeter. So canola is 3 millimeter. How about wheat?
9, I think, 7 or 9.
The thickness of a kernel of wheat is 7 millimeter?
I don't know.
Thickness of a kernel of wheat is about 1/8 of an inch. So 3 millimeters, it'll fit, right? So I put it at 3 millimeter. How about barley? that's a guess, okay? So maybe it won't make it in 3 millimeters. So use the seed and go in there and see if it'll go between the louver. If it goes, because it's small barley, leave it at 3. If it won't fit, go to 4. Now I go with peas. What size now? Don't make it difficult. Do not make it difficult, guys. Use the pea. Go in there as long as it goes between the louvers. That's where you put it. Is that going to be 4 or 5 or 6? Not a clue. But it don't matter. Use the kernel as your measuring tape. Yeah. So if you got big peas, use the big pea and put it in there. That's why I said don't make it difficult. Just take the kernel and go in there. And if it fits, it's good. But never below 3 millimeter.
Aren't you compromising your combine capacity?
Am I?
Aren't you compromising combine capacity?
Question is am I compromising the combine capacity? Okay, I'm glad you brought that up. I'm not going to answer it. I'm going to let you think about it. Okay, so the pre-cleaner is there to take 10% of the good kernels. Only 10, not 20, not 30, 10. Okay, because just remember back here I said that the kernels is the same thickness all the way across. Are the clean kernels on the bottom against the grain pan or up on top of the chaff? They're on the bottom against the grain pan. So I want to shave off 10% of those good kernels and get them down onto the bottom sieve. They'll go through the top sieve and they'll go through the bottom sieve and they go in the grain tank nice and clean. If I adjust this to 6 millimeter and it should be at 3, I'm going to flood the top sieve here with too much material. And then it's going to try to go down to the bottom sieve, and I'm going to plug the bottom sieve. If I plug the bottom sieve, where does it go from there? Nope.
Return.
Nope. I've heard return, I heard out the back, but I heard one that you guys curse all the time.
In the fan.
In the fan housing. There you go. Okay? Why do you think we put a nice door over there that you can plop open real quick and shut it? Because we knew you were going to misadjust the pre-cleaner because you want to get more capacity out of it. Okay? And instead you're getting less because you just plugged the fan, you had to stop for 3 minutes. Okay? So anytime you dump grain on the fan housing, just remember pre-sieve, pre-sieve, pre-sieve. If it's too open, it'll get you in trouble, and if it's too closed, it'll get you in trouble. Okay? So if you stick with that rule, never below 3 millimeter, never above the size of the kernel, life will be good.
Is this just the pre-sieves or the top sieves?
The comment is this just the pre-sieve or the top sieve as well? This is only for the pre-sieve. Only the pre-sieve. Okay? It is kind of critical. So, I mean, it's not critical, but it is, the bottom line is, if you put too much stuff in the fan housing, you plug the fan housing, it should immediately tell you pre-sieve is not adjusted right. So go quickly adjust it using the rule of thumb. Never close it below 3 millimeter, never adjust it any bigger. And then life will be good. Okay, now, top sieve, bottom sieve. Everybody wants the adjustments, the perfect adjustment for every crop. We give you a starting point, okay? I have some secret settings that I keep in my back pocket that every fall after harvest is over, what do I do with my secret settings? In the garbage, okay? You start the season with new settings. We'll start you in the ballpark because in the monitor, we have automatic crop settings. So if you pick wheat, it's going to pick some settings for your top sieve, bottom sieve. When it comes to sieve adjustments, when you're tweaking, another thing to remember is if I close the bottom sieve real tight, the air from the fan needs to come up here, through the bottom sieve, and up to the top sieve. If I close the bottom sieve real tight, how much air am I sending to the top sieve? Practically none, okay? So I need to get, and if I don't have enough air on the top sieve, I can't lift the chaff from the wheat or canola, So now all that chaff falls down with the wheat and canola. It'll pull it down, and now it's on the top sieve. Now I got to do all the cleaning. And whatever can't go through the bottom sieve ends up down back here, falls in the return, brings it across, and dumps it right here again. Now you see why I don't want to try to make the sample too clean in the grain tank using the bottom sieve, because I'm going to increase my return. The more I increase my return, and the further I drive in the field, guess what? The grain pan goes like this. And finally it says, I can't take any more. There, now you got a bunch of chaff in the grain tank. Okay, so how many of you guys experience chaff in the grain tank only? Anybody? Yeah. What do you think happened? Just what Louis said. Okay? Just what Louis said. Okay? So you pushed it to the limit. You stayed in the field too long, going round and round, and it never had time to empty itself. So it built up, and then it said, I'm done. Okay? So usually it's an indication the bottom sieve too tight. So open up the bottom sieve, let the top get more air. And I always try to use my top sieve as my cleaning sieve, not the bottom sieve. Bottom sieve is a wind deflector to the top. So if I open up the bottom sieve too wide, now my wind is coming up to the front, so I can lift all this chaff up in the air. The kernels are a lot heavier than you think, even canola. I can lift all that chaff up. The chaff will travel a lot further. This is the chaff, this is the canola. It'll go like this, and the canola will fall down. Even if it falls down anywhere in here, I'm going to catch it on the bottom sieve.
As long as you're not going too fast, so it comes out the back.
As long as you're not going too fast and it comes out the back. This has nothing to do with ground speed. Okay? This has to do with volume inside. Okay? So if your volume is too heavy, now I need to get more of that air, that 900 RPM that I had. I need to get more of that up to the top. And now how am I going to do that? By opening the bottom sieve. That's why Alvin always runs at 1200, because he does not want to open the bottom sieve. Okay? So you open the bottom sieve, fan speed can come down. More goes to the top. I've combined canola with 4 on the top and 15 on the bottom. Doing a fantastic job and nothing coming out the back end. Because I was lifting the chaff and the kernel had a chance to go and dump in. Bottom sieve's wide open, she falls down, she goes in the grain tank. There's certain crops we go in that we pull the bottom sieve completely out. We don't even use bottom sieve. Wow, how can it do anything? It's not uncommon in corn that you pull the bottom sieve out and only use the top. So again, don't be scared if your dimensions get stupid to where you're more open on the bottom than the top. As long as it's going in the grain tank, perfect. That's what you're looking for. Okay. All right. The adjustment for the pre-sieve. If you have the manual adjust, it's way at the back of the combine. And it has notches on here. Those things come from the factory set anywhere. Okay? Don't go by the notches on the quadrant. But you can calibrate the quadrant if you want to. Okay? So adjust the pre-sieve to 3 millimeter using a Allen wrench. Okay? Put it in there. And then once you know that 3 millimeter is up here, then come back here, loosen this linkage here, and rotate this quadrant to where the last notch over here, that'll be the last notch you ever use. And if you accidentally go to the last notch, your sieve is going to be set at what? 3 millimeter. There you go. So that's pretty simple to remember, isn't it? You'll never go past the last notch. At least I would hope not. So you can push the lever over if you want to, but there's no reason, no notch there. So adjust it, calibrate it to where the first notch is 3 millimeter. Then all you got to remember is the size of the kernel from there. So, all right. Remember also that there's 2 sieves on top, okay? A left and a right. Those two sieves are connected together. All right? The two sieves are connected together by this linkage right here. So if that linkage happened to have slipped because you had some dead mice got in there or rocks or whatever else, there's a little 10mm bolt right here, and there's another one on the other quadrant. You loosen that bolt, and then you grab the handle and you adjust both sieves to where they measure the same gap. So 6mm over here, 6mm over here. Tighten up your bolts. All right? Now when I move this actuator, both sieves are going to stay together. And every time that I go to the field, if a combine is not working properly, what do you think I find? Every time I go, the first thing I do, I walk in, I stick my head in the back, I take a quick look, I said, get me a 10mm wrench. Let's do that right now. Because if you're 1mm off versus the other one, it's impossible to get to pressurize the cleaning system. So one side's always going to be right. So. All right, we're talking a little bit about kill stall a little while ago. The instruction to do the kill stall is right here. Okay? It is cumbersome, but unfortunately, that's the way we have to do it. Okay, so it's 2 hands and a foot. All right, so basically you grab the throttle, you pull the throttle back to an idle, stick your foot on the brake, start applying on the brake, throttle, and hydro handle. Together, push on the brake till the engine dies. The 9250 will not die. Okay, so you're going to have to do another one, and as soon as it slows down to where it starts to buck, turn the key off. But don't turn the key off first, because if you turn the key off first, the ass end of the combine is going to come off the ground, and you just ruin your kill stall. Okay, so throttle, hydro, pull the throttle back, hydro forward, squeeze on the brake, engine 8240 should die. 9240, 9250 probably will not. You're going to have to turn the key off. And then stick your head inside. Now at that point, that's where you're going to take the key and put it in your pocket, right? Just remember, safety first, okay? Because we have a tendency of worrying about our turbocharger. So we restart the engine to keep it cool while we stick our head inside the combine. Is that a very good practice? You ain't getting this cowboy in there. I'll buy you a turbo before I stick my head in there, because I've been through a combine inside with the separator running. That's not how I learned how to adjust combines, by the way. Okay? It's not a pleasant experience. So safety first. If you need to let the engine cool down a little bit, yes, absolutely. Turn it off, put the key in the pocket. Because there's always going to be another guy's going to jump in there and start it on you by accident. Okay, so key in the pocket. All right, so now you've done your kill stall, you go stick your head inside. What you're looking for, all right, is the front of the top sieve here. You see this big pile over here? That means absolutely nothing. Okay, because that's just chaff. When this is completely open like this, that means that there's the same amount of grain all the way across over here. So basically, this first 15 inches of the sieves, of the top sieve, is the most critical area. If that's clean, don't look for kernels on the ground behind. There's none. Okay? Everybody got it? If you see this picture, you should not have any kernels on the ground. If you got kernels on the ground, they came from somewhere else. All right, so let's make it bad. Now I do a kill stall. Remember that same 15 inches we were talking about? How much have I got now open? 15 inches is about here. So this is way too open over here. So that might explain why I have kernels on the ground, because what if my wind is too high? Now I'm blowing that stuff out. You had a question.
When it's even like this, you said there's no kernels on the ground. Can you go 7, 8 miles an hour if it's even?
Okay. Question is, if this is clean like this, can I go 7, 8 miles an hour?
Put it back to 5. I mean, you said you...
If you do a kill stall and you end up to where it looks like this, yes, you can drive 7, 8 miles an hour.
You're going 7, 8 miles an hour, you don't have much in front.
That's what I was going to go. You probably don't have very much in front, okay?
We don't this year.
Yeah, we don't this year. I agree with that. The thing is as long as this is like this, your cleaning system is working properly. Okay, it is almost flawless. If you drive 8 miles an hour and you don't have this, then yes, you will have kernels on the ground. Okay, so let's go back to the next one. All right, so now we had this. Now we got kernels on the ground. And we're driving 8 miles an hour. Okay? What's the problem? Fan speed could be too high because, why did you pick fan speed? Because we are brainwashed that fan speed fixes everything. Okay? That's why you pick fan speed. I knew it. I would have done the same thing. Okay? And that's what we did. This was not just Louis out here. I mean, we had 15, 20, I think maybe even Steve Colburn might have been out there with us when we were playing with that. We were down in Oklahoma there. So, this is why we did this. So there was a bunch of us. Unanimously, we all picked fan speed. So he says, okay, what are we going to do now? Well, let's reduce the fan speed, see what happens. Reduce the fan speed, went and did another kill stall. Now, all of a sudden, you look at this, and this is fully open, this is fully open, this is way too much open, but this one is completely filled. Aha, by reducing the fan speed, I corrected the problem, or I masked it, is what I did. This one here is riding out the back end of the combine. And these ones here are blowing out the back end. So, if the green is not leveled all the way across here, this is what happens. Right now, there's too much grain right here, and not enough right here. So how do we fix that? Take the fan speed, jack it back up to the 50 RPMs up again. What are you going to end up with? Same shit you had before. There you go. Okay, so anytime that you see this when you do a kill stall, that should immediately tell you that has nothing to do with the cleaning system. It's further up. It's back to my grain pan not level, and that means rotor speed and module height.
But Louis, when you're in canola, you don't want that rotor speed too high.
Okay, Alvin says, when I'm in canola, I don't want that rotor speed too high. In the last 5 years, it is almost impossible to peel canola, from what I found. Okay? It is getting the new genetics in canola. It is very difficult. You know, my secret speeds now in canola is 850 RPM. It used to be 600. That was my setting. 600 on the rotor, 600 on the fan, put the concaves or modules at 15, go combine it. Okay? Life is good. Now all of a sudden, whoops, maybe not so good.
Yeah, but if it's dry, you're blowing that canola out the back.
Well, I'm hoping that this year that we're back to normal again and it's dry, and maybe my 600 and my 600 will work again. But you know what? I don't think it's going to work because the dang pod are going to be even harder to bust up. Okay? So, let's keep that in mind. We're going to go to the next one. Alvin says, let's go in there and let's change the rotor speed. So that's what we did over here. We just went and changed the rotor speed. Okay, we changed it 50 RPM. Well, we're making some headway. We moved it from here to here, and it's a little open here. But it's still not pretty enough because I've got nothing on this side over here. So what are we going to do next now?
Did you decrease or increase the rotor speed? You increased it?
Over here, we decreased the rotor speed. So now somebody got bright. Brainwave came in. I think that was Steve Colburn. I'll blame him for it. He said, Larry, let's jack that rotor speed right up and see what happens. Okay? So all it did is it took everything from here and then shoved it all on this side. Still not fixed. Now, I know it's going to be hard to see, but underneath here is your modules. Okay? Pinch point should be bottom dead center, 6 o'clock. Okay, so try to imagine this. That's the closest that the module is to the RAS bar. And then if I use both hands here, because there's two modules, okay, it's a 4 millimeters in the middle. That's where I got my module set. Now the curvature of the rotor and the module goes like this. It goes like this, and it gets here. It's wider. You follow me? RAS bar distance to the module is this wide at the top, but bottom dead center, it's 4 millimeter. So now, sitting in the seat all the time, okay, the rotor turns like this behind me. Once I increased the speed of the rotor, what I did is I drove all that canola past that 4 millimeter over to the other side. And when I slow the speed down, I can't drive it past the pinch point, so it wants to drop over on that side. Okay, so for you guys, you're going to have to look this way. All right? So here I am. If I slow the rotor speed, it's going to put the pile on that side. If I increase the rotor speed, it's going to put it on that side. Because you're the driver now. You're sitting in the seat. Okay? As long as I can drive it past the pinch point, it's going to overload the left. If I slow it down, it's going to overload the right. Now, what's going to happen if I increase my gap over here? Which way is my pile going to move? The pinch point is wider now, so if I maintain that rotor speed at 600 RPM, and I open this from 1/4 inch to 1/4 inch, 4 millimeters to 20 millimeter, is the pile going to move to the left? It's going to try to drive more material past that pinch point over to the other side. And if I tighten it up, then it's going to grind it out and put it on this side. So now it's up to you to figure out which one do I do, modules or rotor speed? Okay? You've got to do the combination of the two. And then eventually, once you find the sweet spot, okay, now all of a sudden you're going to end up to this. So once I hit the sweet spot, now I have evened up that grain pan all the way across, same amount of grain, it cleans up, life is good. By the way, I didn't touch any of the setting of the cleaning system. I didn't touch my fan speed, I didn't touch my pre-sieve, I didn't touch my top sieve, and I didn't touch my bottom sieve.
So as your crop varies as you're going down the field, that's going to vary too then?
Oh, there's always a guy that's got a better question. As my crop varies as I go down the field, that's going to change too, isn't it? Why do you think we came out with automation? Because you will never change it, okay? So now we have automation that will change it on the go for you, which maybe will save you some more grain. But you don't want to give Louis any more money for automation.
But now, Louis, does that automation, does that act that fast? like within,
Okay, question is automation, does it act that fast? And it's a very good question because it will move a lot faster than you will because you're not going to change it. You're just going to drive through that spot, and it's one of those, oh well, I know it's going to get better when I get on the other side. So that's why for the inexperienced operator, it's probably a good tool to have because you sit him in there, he doesn't know how to adjust it, he's just your banker. He just sits in there and does one of these jobbies.
so are you saying if you go over a hill with some lighter canola?
Yep.
It's going to adjust for that hill, and then down in the low spot it'll look
Question
up.
is again, if I hit the top of the hill, is it going to adjust for the top of the hill? If it senses that it needs to, it will. Okay? And bottom of the hill, is it going to adjust on the bottom of the hill? If it senses that it needs to, it will.
Or is it when you're going to be in the bottom of the hill, and it'll be adjusting for the top of the hill?
Comment is if I'm at the bottom of the hill, it's going to be adjusting for the top of the hill. That's back to your reacting not fast enough. Okay? Automation is not totally foolproof. Okay? But will it change something for you as you go? Yes, it will. So it will get your money back after X number of years. Okay? I'm not going to say 2 months. But automation is by far works very well. Is it absolutely foolproof? No, it's not. Sometimes it still need a guy that might know that I need to adjust my parameters. Okay? And for example, you know, I'm sitting over there. I need my rotor speed to run at 800. I'm going to pick 800. Okay? So if I got my automatic crop settings set to where I say I need 600 on my rotor speed, it's going to drive you absolutely crazy because if it needs to go to 800 for the canola that it's doing, it's going to tell you shift gearbox, shift gearbox, because they can't shift the gearbox. Okay, you're in between. So now you're going to have to go set your range to say don't go below 800, but don't go below 9, or don't go above 9, or 825. So you set the range to where it stays in those parameters, and it doesn't throw you that stupid alarm that says shift gearbox. Or if I don't want it to go any higher than 675 or 690, I'm going to say don't go any higher than that. So it still takes a little bit of intelligence.
So who programmed the automation? Like, is you that, or is that?
All right, who programmed the automation? Whoa, Steve Colburn. Okay. It's a guy that it would blow your mind if you saw the data that goes behind a certain crop. The crop that we have authorized to be in there, the brain in the operation back there, it's an Excel spreadsheet that's 40 miles long. They've got all the data in there, all the data set that it takes. So what it's going to do is it's going to look for, it takes a picture. First of all, is it monitors the pressure between top sieve and bottom sieve. Okay? So once it knows that it's not loaded properly, it's going to start doing some adjustments to try to compensate for the cleaning system that's not loaded properly. Okay? So it's going to do top sieve, bottom sieve, fan speed, the pre-sieve, rotor speed, possibly vane position. Okay? It won't do the concaves. Sorry, still got to be me. We haven't put that one in there. So that's why I said I still need a little bit of intelligence, because if the module needs to move up and down, I got to figure that one out. So if it's doing all its thing and it won't fix it, then it's up to me to move this one. So, and then once it's done this, then it's going to take a picture with the camera, and it's going to look at the picture and it's going to say, there's too much debris in there, so we need to tweak it some more. The pressure sensor tweaked it, but the camera is going to tweak it some more. So that's kind of how the system works. The nice part is like I said, on uneven crops, which we all have, from operating in the low spot versus the high spots, if we have a standard combine like this one, none of us is going to change the settings. I mean, we already got all the sweet spots, right? Geez, I don't want to lose that, so you leave it. You drive through it and go down the other side. It'll get better when I get there. Now you have someone that's in there tweaking it for you as you go through those spots. So that's how it pays for itself.
We'll see if there's more money in the bank.
Well, I've got an old saying that I keep saying all the time, okay? The more grain in the tank is more money in the bank, okay? So if you throw it on the ground, it ain't in the tank, it ain't in the bank. So does combine throw over? Absolutely, okay? How much? This is our job to minimize it. Understand how the combine works and minimize it, and get as much as you can in the tank.